Okay, so let me start off by saying this. The AI community loves to come up with new names for very old ideas. And this time, the buzzword is context engineering. Now, this all started off with this tweet or post from Toby, who is the CEO of Shopify. So he says, I really like the term context engineering or prompt engineering. This is the art of providing all the context for the task to be plausibly solvable by the LLM. And a lot of people agree with him. So here's a tweet from Andre Karpathy, +1 for context engineering. Context engineering is the delicate art and science of filling the context window with just the right information for the next step. So I'm going to cover what context engineering means and how you can manage your context. Also, but here are a couple of other takes. So here's Ankur. He says, as the model gets more powerful, I find myself focusing on efforts on context engineering, which is the task of bringing the right information in the right format to the LLM. And here's another definition that I covered in one of my previous videos. So prompt engineering was coined as a term for the efforts needing to write your task in the ideal format for a LLM chatbot, although I don't agree with just the chatbot part. Context engineering is the next level of this. It is about doing this automatically in a dynamic system. I personally think prompt engineering actually covers all of these ideas. Prompt engineering is just not about writing a single set of instructions. You can dynamically populate that, and we have been doing this for quite a while. But we have yet another term, context engineering. And I think we have been seeing this pattern for quite a while. So this happened with retrieval augmented generation, which is essentially information retrieval. We have been doing that for decades now. Now, here's an interesting article from LangChain. I'm going to cover another interesting article of how long context fail, which I think is a lot more relevant because it talks about different scenarios in which you're just filling up your context with irrelevant information and how to mitigate those. So we're going to cover that later in the video. This article tries to make a case for context engineering. Now, according to LangChain, context engineering is building dynamic systems to provide the right information and tools in the right format such that the LLM can plausibly accomplish the task. And the focus is that context engineering is about systems, not only user instructions. The reason they say that the system is dynamic, so based on the needs of your agent, you can dynamically provide the context and change the context. And that dynamic context is going to come up with the right information, and it will need the right set of tools. Now, in order to convey the right set of tools and information, you need the proper format in which you're going to convey those instructions. And that's what we have been doing with prompt engineering. But I think the most important part is, can it plausibly accomplish the task, which I think is very important. So whenever you're building an agentic system or any system on top of these LLMs, you need to look at the underlying model and figure out, even if you provide the right context to this model, can the model actually accomplish this task? Okay, but first let's look at the difference between context engineering and prompt engineering based on what LangChain teams thinks. They are trying to present prompt engineering as a subset of context engineering. So here they say, even if you have all the context, how you assemble it in the prompt still absolutely matters. The difference is that you're not architecting your prompt to work well with a single set of input data, but rather to take a set of dynamic data and format it properly. So it's just an extension of prompt engineering for dynamically changing data and dynamically changing set of tools. Now, you're going to see a number of different articles coming up on context engineering, but the main idea is that you want to provide the most relevant information to your agent or model at the proper time. And if you stuff irrelevant information in the context of the model performance is going to decrease. So let's look at some scenarios in which we are providing wrong information to the context of the model. I think in order to understand the need for context engineering, it's very important to understand the failure cases that can occur in the context window of your model. So this article is from Drew, who is an independent consultant, and he presents very interesting ideas on why we need to look at the context of the model, even though if you have long context LLMs and you just can't stuff things into the context of the model and pray that the LLM will be able to solve all your problems. The first one is context poisoning. And this happens when hallucination or other errors make into the context where it is repeatedly referenced. Now, the term itself was coined by the DeepMind team behind Gemini 2.5, and it's presented in the technical report. So they say that when playing Pokemon, the Gemini agent would occasionally hallucinate while playing. Now, the reason this happens is that there is hallucination or misinformation towards the goal of the agent. So, for example, if you have a multi-turn conversation and at single turn there is hallucination, the model hallucinates regarding its goal, propagate throughout the conversation, and the model may start focusing on this hallucinated goal, which is going to result in irrational behavior from the agent. I think these are very interesting ideas, especially if you're building agents. You definitely want to think about some of these. The second idea is regarding context distraction. Now, this happens when context grows so long that the model over-focuses on the context, neglecting what it learned during training. So if you're using a single agent, or maybe even in a multi-agent system where you're sharing context, the agent is going to take certain actions throughout a multi-turn conversation. It turns out that the agent can be distracted by repeated actions, and it could start focusing on those actions rather than trying to come up with novel ideas to solve your problem. So for example, the Gemini Pro team said, in this agentic setup, it was observed that as the context grew significantly beyond 100,000 tokens, the agent showed a tendency towards favoring repeated actions from its vast history rather than synthesizing novel plans. And you probably have seen this with coding agents like Cursor. Sometimes they get stuck in an error or a bug and they are not able to figure out the solution. And in those kind of situations, you have to create a new session. Now, the alarming thing is that this distraction ceiling is much lower for smaller open weight models. So for example, a Databricks study found that the model correctness began to fall around 32,000 tokens for Llama 3.1 405B and earlier for smaller models. So you need to be aware. You don't want to have repeated action in your context. There are ideas on how to clean up the context of your large language models. We're going to touch on some of those later in the video. Okay, the next one is context confusion. And this is when superfluous content in the context is used by the model to generate low quality responses. So this is critical, especially with agents where you have a number of different tools with tool descriptions. So there are a couple of studies. In one of them, they found that every model performs worse when provided with more than one tool. And another study found that design scenarios where none of the provided functions are relevant, we expect the model output to be no function call. But since they are in the context, yet all the models will occasionally call tools that aren't relevant at all. And this is especially worse for smaller models. So if you stuff tool descriptions in the context, and even though the user request is not relevant to any of the tools at all, smaller models will tend to pick up a random tool just to try to use it rather than actually focusing on the user prompt or query. There is also seems to be a limit on how many tools you can put in an agent. I personally recommend to limit it to 10 to 15. This is based on some of the conversations that I have with folks in industry. But here, they referred to the study. They offered Llama 3.18 billion quantized model 46 tools. And it actually failed on every single query. Now, when they reduced it to 19 tools rather than 46, it had success in some of the calls. The last one is context clash. And this happens when you acquire new information and tools in your context that conflicts with other information in the context. Now, this is a more problematic version of context confusion. So the bad context here isn't irrelevant. It directly conflicts with other information in the prompt. And this also actually kind of addresses how you prompt different models. So you probably have seen articles on prompting reasoning models is very different from prompting non-reasoning models. So for example, here's the proposed structure of how you are going to prompt O3 or O1 type of models. So you have your goal, return format, warnings, and the context itself. The team at Microsoft and I think Salesforce did a study which shows the difference between providing all the context all at once. So you dump everything in the beginning of the conversation and then providing the same context over multiple different turns. Now, it turns out this multi-turn sharded instructions is a bad idea for LLMs. And the reason is that you're progressively adding more and more context in multiple turns, where some of the information may look like that it contradicts the prior information. So here they say the sharded prompts yielded dramatically worse results with an average drop of 39%. And the team tested with a range of models. Now O3 was the worst because it dropped from 98% to 64%. Okay, so we talked about all the problems with filling in the context, but now let's look at some of the solutions which will ensure that you have the right information at the right time that you can dynamically feed into the context of your agent or LLM. And the first one is the good old RAG or retrieval augmented generation. So this is an act of selectively adding relevant information to help the LLM generate a better response. Now, this can help just beyond search. So for example, if you have an agent that has access to 50 tools, you can use a RAG based on the user query and the description of the tools to selectively choose a smaller subset, which is relevant to the user query. And that is going to be put into the context of the agent. So instead of, let's say, 50 tools, the agent at that step is going to only see 10 tools, and then it can probably generate much better responses based on properly using those tools. Now, the second idea is regarding context quarantine, and it's an act of isolating context in the dedicated threads, each used separately by one or more LLMs. So this is tied to the idea of a multi-agent system. And this is tied to this idea of handoffs in a multi-agent system that was proposed by OpenAI. So you will build specialized agents with their own context rather than a global shared context. Then they propose context pruning, which is an act of removing irrelevant or otherwise unneeded information from the context. So if you have built RAG systems, probably re-ranking is a really good example of this, that initially you retrieve, let's say, 1,000 chunks, and then you have the secondary re-ranking steps, which further reduces the context that is going to go into the LLM. So there is a specialized model called pruning that was, I think, presented back in January 2025. It seems very interesting, right? So basically, it removes the irrelevant context by looking at the user query, and then it presents that concise context to the model or agent. The next idea of managing your context is context summarization. So it's the act of boiling down and cured context into condensed summary. We have seen this with chat models. So ChatGPT does this. Even for some of RAG implementation, you want to do that. So let's say if you're reaching towards the end of the context window, you want to summarize some of the earlier conversation that has happened, right? And that way you can preserve most relevant information that the LLM is going to focus on. Now, interestingly enough, going back to that Pokemon example, so even though the Gemini model has a 1 million context window, or in some cases, I think they said it could go up to 10 million context window, seems like it has a working memory of 100,000 tokens. After that, you start seeing context distractions. But context summarization is not easy because you need to make sure that you are summarizing only the relevant information. Otherwise, that is going to result in context confusion and distraction. And the last idea is to use some sort of context offloading mechanism, which is an act of storing information outside LLM's context, usually via a tool that stores and manages data. You could potentially create short-term and long-term memory systems. Okay, so in this video, we looked at context engineering, some of the ideas relevant to how to manage your context. We'll be creating some more content on a practical example of context engineering. Although personally, I still think it's just relabeling some of the old ideas that we have seen before. But do let me know what you think in the comment section below. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.